Good morning, everyone. I am John David LIBATON, and I am here to present to you the Chapter 9, which is entitled Your Brain on Pointers.
A pointer is a special variable that is used to store the address of some other variable. A pointer can be used to store the address of a single variable, array, structure, union, or even a pointer. Why we should use pointers? Pointers allows us to achieve call by reference, write functions which change their parameters, handle arrays efficiently, handle structures or record efficiently, create linked lists, trees, graphs, and etc., put data onto the heap, create tables of functions for handling windows, events, signals, and etc. Already been using pointers with scanf. Care must be taken when using pointers since there are no safety features. As C programming is such a low-level language, it is difficult to do anything without pointers. We have already seen that it is impossible to write a function which alters any of its parameters. Mindwash drill. Pointers can also able to writing of linked lists and other such data structure. The standard library together with the Windows 97 and Windows NT programming environments use pointers to functions quite extensively. Mindwash drill table. These are the ways of declaring pointers. 1. Pointers are declared using star sign or the asterisk. Number 2. Declare an integer. Int I, semicolon. Declare a pointer to an integer. So, in this example is P is the pointer of the int. Number 4. There is some debate as to the position of the star sign. P is a pointer of int.
So here is another mindwash drill table. Pero kani is more detailed na. Katuganiha is kuan man to. Mga ways unsaon pagkuan sa pointers pag declare. Kani kay i-declare na unsa na is iyang structure. So tanawa int then star sign then pi. So gi-explain diri sa picas table nga ang pi is a pointer to an int. Then and so on and so forth. Antod na sa char nga type. The declaration of the variable tells the compiler to number 1. Reserve space in the memory to hold the integer value. Number 2. Associates the name A with this memory location. Number 3. Stores the value 5 at this location. Pointer and the indirection operator. Pointer and the indirection operator has two fundamental operators with the pointers used. And these are number 1. Address operator and number 2. Indirection operator, the star sign. So this is a sample program of using a pointer. So kanang nasa ubos kanang mga printf statements kana printf modulo d %d kay mo output na siya og 10 kay since ang kanang variable nga p diha is di man na siya ordinary variable pareha sa ubang integer variable. So sa kani nga program is ang a nga variable kay mo nag-store sa address of some other variable. Since ang p kay variable man sad, ang compiler kay dapat mo-provide seg memory sa kana nga variable. Then any type of pointer get 2 bytes in the memory. So mo ni siya ang sample nga code. As per ang giingon ganiha, tanang pointers or any pointers will give 2 bytes each. So, ang P1, P2, ug P3 kay pointer man sa int, float, ug char. So, 2 bytes ilahang bytes sa memory. Memory and pointers. So, mo ni siya ang sample program. This is a sample program of memory and pointers. Suppose if 3 pointers are declared for int, float, and char, all 3 pointers will occupy 2 bytes. This is because all the memory addresses are integer values, ranging from 0 to 65,536. Thus, we can say that a pointer, irrespective of its type, is storing the address as integer values, and each integer requires only 2 bytes. Pointers and addresses. This is a sample program of pointers and addresses. So, mo na siya. Points the address in pointer p as integer and so on. Then ang output for this program is -12 65,524, FFF4, FFF4. So, sa kanang unang answer, the first answer kay negative value siya. Tungod kay ang range of pointers is from 0 to 65536 or 65,536, di ba? Pero ang variables kay na-allocate og memory from top to bottom from 65,535, 6,500, 65,534, and so on until 0. Maong negative ang answer niya. Sa first answer, katong negative 12. Pointers and expression. Like any other variables, pointer variables can be used in expressions. In a program, all the following operations are valid. Number 1, C allows us to add or subtract integers from pointers. For example, sum is equals to sum plus the 1. P1 is a pointer of sum. Also, shorthand operators are allowed. Sum plus is equals to pointer P1. Answer is equals to pointer P1 plus plus. This will cause the pointer P1 to point to the next value of its type and the difference the value. So, atong i-illustrate ang number 2. Muna siya ang sample program for differencing or addressing. Kuan gamit ang pointer. Like that. Number 3, as well as to subtract one pointer from another. So, ang pointer, pwede po siya i-subtract from another pointer. So, muna siya ang sample program. Then, this program will output 20, 20, then 10. Number 4, P1 and P2 are both pointers to the same array. Then P2 to P1 gives the number of elements between P1 and P2. So, pointer P3 is equals to pointer P2 minus pointer P1. Number 5, two pointers can also be compared, such as P1 is greater than P2. P1 has an inequality with P2. P1 is not equal to P2. These comparisons are useful only while using string or arrays. Number 6, two pointers cannot be multiplied, divided, or added. Null pointer. Null pointer is a special pointer value that is known not to point anywhere. Using any one of the standard header files including stdio.h, stdlib.h, and string.h to initialize a pointer to a null pointer. So that is the example of that. So null pointer, before inspecting the value pointed, most of this ang example. So pointers to pointers. Pointers store the address of a variable. Similarly, the address of a pointer can also be stored in some other pointer. Muna siya ang example of pointers to pointers. Ang pointer to an integer or pointer to an integer, then pointer to an integer. Ana na siya. Pointers and array. When an array is declared, the compiler allocates a base address and sufficient amount of storage to contain all the elements in the array in continuous locations. The base address is the location of the first element, index 0 of the array. Suppose we declare the array A as follows. Static int A, open and close and bracket, and nasa sud ang 5, then is equals to open and close braces, din ang sud kay 10, 20, 30, 40, 50. Suppose the base address of the array A is 100, and because the integers require 2 bytes each, the name A is defined as a constant pointer pointing the first element A, open and close bracket, and therefore the value of A is 100. The location where A, then the index is 0, is stored.
Pointers and functions. As discussed earlier, the function passing the array parameter uses call by reference mechanism. So, muna siya ang sample program that swap two numbers. Run ana diha kay ang duha ka number is swap. For example, 2 is swapped by 1. Pointers and array. In the call by reference, the function prototype is declared as pointers. The dereference pointers are used in function definition. When the function is called, the addresses are passed as actual arguments. Common errors. A pointer contains garbage address until it is initialized. If we try to dereference this pointer, then it will not give any error, but it will jump to that address and assign the value in that address. This is a logical error which a compiler cannot detect. Memory allocation. Number 1, static memory allocation. Number 2, dynamic memory allocation. The conventional way to use an array is by declaring the array with its size, and since the size of array must be a constant, so it leads to either wastage or shortage of memory because the array is allotted memory at the time of compilation of the program. Static memory. Static memory is the memory allocated at the time of compilation. Dynamic memory. Pointers can be used to allocate memory at the time of execution of the program. So these are the functions and the task of these functions. The malloc functions. It allocates the requested number of bytes and returns the starting address to a pointer. The calloc functions allocates the requested number of bytes, initializes them with 0, and returns the starting address to a pointer. It allocates the non-continuous memory. The realloc function reallocates the size by increasing or decreasing the number of bytes and returns the starting address to a pointer. The free function frees previously allocated space. And that would be the chapter 9. Thank you for watching and thank you for listening. Goodbye.